security context constraint. So shortly we call that as SEC. So we'll see that. So to understand the SEC, we'll create an analogy with something we already know called AC Linux. So SEC is actually a security mechanism, or you can say a security scanning mechanism, which is there at the OpenShift platform level, and which is an inbuilt mechanism. So this is specifically on the OpenShift platform. So you will not have the SEC by default in the Kubernetes. If you want, you have to create the SECs in the Kubernetes. But here, as a default scanning mechanism or security mechanism, we have SEC inside the OpenShift. So to understand this SEC, so we'll understand something at the OS level. So I think we already know about something at the OS level, like at the server level. We have something called SE Linux. Is there? Typically, you see in the real systems, we have this SE Linux concept. So what this SE Linux is doing is like it is going to provide me a context-based security for servers, right? Like what kind of context is that? Every entity, so every file system, processes, all these things will be given a context, even including a port. So everything will be given a context. When some user is going to access that entity, so whatever may be the file system or process, when the user try to access it, if the entity is not in the context of that user, so for example, if I'm coming into the system as a web user, so I can access the file systems which are related to the web pages. Like I can access the .html files or .css or .js. So like that files I can access. If I move out of the context and try to access some files like database files, if I try to access .db file, I can't able to access it. So SEC, if the SEC is in active state, it is going to actively prevent me from accessing it. So this is a high level of security. Like I have get into the system, but to provide a context-based access. So we have the XCC to do that mechanism. The default security available, the RHEL 7 or RHEL 8, you can use that security mechanism to provision a context base. So SEC can operate in 3 different modes. So the first mode is enforcing mode. So we know that like enforcing mode, that SE Linux will be completely in active state. And the permissive mode, it is a passive mode. So SE Linux will not be in active, like it's not going to implement any policy, but it will have a record. So whatever the security breaches are happening inside the server, it will have a record, so that during the auditing time you can fetch that record and you can see what the some troubleshooting, can see what is the issue that security breaches. And the last thing is the SE Linux will be operating in a disabled mode. That means you're just switching off the SE Linux in the competition. So basically, mostly we'll use it for the preventing a file system. So SE Linux can be used for other things also, but most majorly for 70% of the time we'll be preventing the file system. So file system protection will go for SE Linux concept. So the reason for understanding the SE Linux now is we are going to understand something, a parallel phenomenon in the OpenShift container platform. So there we have something called SEC to do this similar job. So here the SEC, shortly called as SEC, we will call as a security context constraint. So that restricts access to the resource, and so this is a major of protecting this element will be containers. So here on the server level we are protecting the file system. Here we'll be protecting the containers. And similar to the SC Linux, SEC also have 8 different modes of operation. So it has 8 different modes. So in our curriculum we'll cover we'll see these 2 different modes, like any UID and restricted. And each mode has a peculiar function, or you can say particular function to do it. So this SEC concept is a very broad concept. So in the OpenShift security, you will read more about, or you can have a lot of use cases of using the SCC. But in our here in our section, we are going to see about at the introductory level. So what is SCC? What are the modes are there in the SCC? How to utilize that? So with one specific use case, we are going to understand how to use the SCC. So, but if you take the SCC itself, it is a very broad topic. So we are not able to fully justify the SCC topic here. So we can able to just see at the introductory level how to use the SCC. So here we are going to see only two modes, like any UID. What is any UID and what is a restricted UID. So we'll see this first and the last. So this will be the most privileged mode, and this is the least privileged mode. There are other modes which is specific to the other specific use cases. So unfortunately, we will not able to see that all the use cases over here. So these modes are used for particular use cases, as the name indicates. So we're not able to use this here by understanding all the use cases. We'll just use it for one particular use case. And mostly we are going to prevent the containers, the container access. We are going to provide a security for container mechanism or container which is running inside the OpenShift. So we are going to prevent the container. So we are going to classify the container in different categories. Depending on that, we are going to protect the container from the vulnerability. So this is what an SCC is, and we'll go and discuss detail about it. So SCC, which is a security context constraint, and OpenShift provides security mechanism that restricts access to the resource, but not to the operation, not to the operations of the OpenShift. Okay. What does this statement means? The operation, not the access. Like here, the access means the resource which is getting deployed. For example, when I want to deploy application, first I deploy that. I will create the deployment file. Then the deployment file will be created. Through that, your request will go to the scheduler. Scheduler will schedule the application on any one of the worker node. Then after scheduling it on the worker node will get the image, and it will inside the worker node we have kubelet agent, so that will get the image and all these things and build that container. And after the container is going to run. And this operation, this is called operation. So this will not be prevented by the SCC. The operation will not be prevented, but the resource access will be prevented. Like when the container is going to come up, if the container is not satisfying the SCC requirement, then it will be prevented from running. So that time it is going to prevent it. But the normal operation, like scheduling, then the kubelet, getting that image and all this operations will not be prevented. Normal operation will continue as it is, but it is going to prevent only that the resource, when the resource is going to get deployed, because the resource is the prime concern for us. When the resource gets deployed, that time it's going to prevent that resource from running. But normal operation continues as it is. So the normal operation, if you want to prevent the normal operation, you have to use something like a role-based access control. So through that you can prevent the normal operation from happening. So for example, I don't want to a particular user to run the deployment itself. In that case, if I want to prevent that, I have to use a role-based access control for that user, so that I can prevent that user entirely from doing that operation itself. So here we cannot do that using the SCC. So SCC basically controls something called running a privileged container. So in our topic, we are going to see, in our section, we are going to see the privileged container. So we'll see what is a privileged container and how to run that privileged container. So that is the use case which we are going to see in this section. So later on I'll elaborate about this privileged container. Then the SCC also controls something called capability for a container. So what is the capability of a container? Capability in a sense, the container itself, which is running as a process, which is also having a miniatured OS inside it. So it has got its own OS, miniatured container OS. And there is a requirement to manage the container OS file system. So normally when we have the OS, we have the file system permissions. So like I can create file, I cannot create file, I can modify the file, I can edit the file. So like that, we have at the OS level, you have file system permissions to manage it. Similar to that, at the container level, we call that as a capability. So if I want to give some capability to the container, I can do that using something called, I can add that using the SCC. For example, let me go to the lab. So here I have two containers, two pods running. Inside the pod I have the container. So if I take a remote shell of this one, if I do CRSH, since I have only one container inside this pod, it will automatically get me to that container directly. If I have multiple container, I have to specify here the C option. Then I have to specifically get to that container. So here I'm directly getting to this MySQL container, which is running inside this MySQL DB pod. So here I can create a file. I can use a touch command. So I can use touch command. I can create like myfile.txt. So I'm creating a file, and you can just do ls hyphen and list that file. So if I listed file, you can see I have the file as created. So you can see the permission for the file is a normal Linux permission. You can see the permission for that file, and this is actually managed. So when I'm creating a file, I'm able to create it. So when I use the touch command and create a file, I'm able to create the file. Okay. So this capability, this is called capability. So like creating a file, normal file system permissions. So creating a file, creating a directory, executing a file, all these things comes under something called capability. Like you can take to the next level also. You can creating a user and executing a privilege command. These all things comes as a capability. So you can add a capability to the container. So you can say you can give permission to create a file inside the container file system, or you cannot. You can remove that permission. Even you can remove the permission. When I'm taking a remote shell, the shell is actually available. So I want to prevent that from happening. I don't want to give a remote shell to the user. So in that case, I can prevent that using the capability. So this is what capability. So when you are going to study more about the OpenShift security and container security, there you will learn more about how to control this capability. And one of the prime factor to control it, that controlling and enabling this permission, enabling, disabling the permission, is SEC. Through SEC, you can able to control that factor. So SEC also used for that. And next is using the host directories as a volume. So SEC controls that. Like normally the container runs as a process. So the processes are normally not allowed to access the file system, so access the directories. In case, for example, we have seen one of the case like in the bind mount. So in the bind mount storage, where the application container which is running inside the worker node want to use the node on which, or use the host on which it is running as a storage point. In that case, it has to access the directories on the local host. So how to provide the access? Normally the kernel will not provide the access. So to get the access for that, we will be using the SEC to get that access to the particular host inside a particular host. So this is what using the host directories as a volume. So you can use the SEC to do that. And each container has a SELinux context. So to change the SELinux context of a container, you can do so by using the SEC. And in some cases, I want to change the user ID. So you can see when I create this file system, so when I create the file inside this container, you can see there is a user ID. So there's some random user IDs there. In some scenarios, I need to modify this user ID. So I cannot directly modify it. To modify this user ID, I have to use the SEC to modify it. So OpenShift it's not going to allow you to do these things directly. So these things are achieved through the SEC, using the SEC, and SEC will have some kind of a role-based access control. So to use the SEC, you should have a permission. Then only can able to modify the SEC and all these parameters. So using the SEC, you can able to achieve these things. Not only that, there are a lot of use cases for that. Just we are understanding some 5 use cases, the major 5 use cases. Apart from that, we have other use cases also. So like controlling the supplementary group, like supplementary file access. So all these things you can do that using the SEC. Okay. So as I told, we are going to understand only one use case. So these are some of the things which we can achieve with the SEC. We are going to understand one use case. That use case is what is first we understand what is a privileged container, and this privileged container will not be allowed to run by default in the OpenShift. The privileged container will be prevented by the OpenShift, that is prevented by the SEC to run in a default way. So in that case, what I have to do is, if I want to run the privileged container, so I have no other go, I want to run it. So in that case, what I have to do is, I have to do some process called privilege escalation process. Using the privilege escalation process, I will be running that container. Okay. So first we'll understand what is a privileged container. So privileged container is one which is going to run as a root process. So like the container, so for example, we have a worker node. Inside the worker node, I have the pod. So pod is a wrapping element. Inside the pod, I will have the container. Okay. And how this container is going to run? So from the basic studies, you might know that the container is going to run as an isolated process. So the container is going to run as a process. So if you typically examine any process on the Linux system, not the container process, any process, if you typically examine it, so like you can use ps using this command. If you examine the process, you can see any process is going to have something called a user ID. So our user is associated with that process. So the user may be a root user. So if you take this process is running as a root. So there are some process which will run as a system user. You can see some process running as a system user. You can see here a cron. The cron is a system D process or system process. You can see that this process is running system, or some process there are running as a regular user. So regular user, like student user who have generated some process. So that process is running as a student user. So generally, when you classify the process can run as a root user, or the process can run as a non-root user. So you can, that way you can classify any process. Either it can be a root process or it can be a non-root process. Okay. So the container also the similar case. Container will run as a process, and it has a capability to run as a root process, and it has a capability to run as a non-root process. Okay. So the container can run as a root process, or it can run as a non-root process. And I don't have any problem with non-root process. So when the container runs as a root process, I have a problem. Like when the container runs as a root process, that is actually a vulnerability. Like the root process can directly interact with the kernel, and it can for the kernel. You can have the, like if the container is running as a root process, through the root container, it can able to compromise the entire system. Like in from a security perspective, you can able to compromise the entire system. So this is a vulnerability. Like I do not allow the container to run as a root process normally. So at the enterprise level. But if I don't have any need, I have to run that as a root container. For that, we have to follow some procedure. That's what we are going to do here. So when a container runs as a root process on the worker node or on the host on which it is running, that kind of a container is called a privileged container. Okay. So just we are concerned with the container. So forget about the pod. So pod is there. So there is no disturbance over here. You will have the pod. Inside the pod will be the container, but we are concerned with the container. How the container, what's the mode of the container running. So we are concerned with that one. So when the container is running as a non-root process, I don't have any issues. That is, the OpenShift doesn't have any issues. It will allow that container to run. But when the container try to run as a root process, there is stamped as a privileged container. So it will not normally allow to run. So who is going to prevent that? So that will be prevented by the SEC. So any application deployment you're doing, so that will have a SEC associated with it. SEC will scan your application. So for example, here you can see we have 2 pods running over here. If you just do OC describe pod, so for example, if I take MySQL, so here if you go and grep for SEC, you can see that it has got an SEC called restricted mode. So by default, the mode of SEC will be restricted. It will be in a restricted mode. Actually, we have 8 different modes of SEC. So also you can look into the other. You can see this container also, like PSQL. OC describe for PSQL. For there you can see this is also having a restricted. This is default. So defaultly when you create this one, the SEC will be scanning it. So default SEC mode will be restricted. Okay. So the restricted mode, how it is going to work is the restricted mode. So will come back to this picture again. So we have the container which is running as a process inside the pod. When this container is running, so default mode is default SEC mode is restricted. The restricted mode, what it will do is when the container runs as a non-root process, the restricted SEC will allow it. So will not have any problem.
But when the container is trying to run as a root process, SCC, the restricted SCC, what it will do, it will prevent that container from running. So it's going to prevent it. That will won't allow it to run. It will allow the deployment. So the operation level, we will not have any problem. We can able to deploy it. We can able to create the deployment. We can able to create the service and all these things for that pod or that application. But when the container inside that application or inside that pod is going to trying to run, if it is a privileged container, if the SCCR finds out that that's a privileged container, then it will prevent that from running it. Okay. So in that case, in some scenarios, we were forced to run the container as a root container because we don't have a choice. We have to run that as a root container. In that case, if you're having that vulnerability, with that vulnerability, if you're running that container, so we have to follow a procedure called privilege escalation. So I'm going to escalate the privilege to run this container. So we are going to see how to escalate, how to do that privilege escalation. There are two choices. One is you can do a privilege escalation. In the privilege escalation, technically you're doing nothing. So technically you're not going to change. It is going to still run as a root process. You're doing nothing over there. And that is one. Other way is to change the user ID. So the root process, that is the problem. So I can change the user ID using the SCC. That is the other way you can do that. Here you are technically modifying the user things. So, but if I modify the user ID, like from the root to non-root, so then I may face some issues with that application. Maybe the application may not work properly if I change that thing. So in some cases, I don't have any choice. I have to run that as a root with a vulnerability. So we have to follow a privilege escalation process. The privilege escalation process, we are going to go through, like we are going to inform who are all the authority in that deployment. Like we are going to inform the project manager, the cluster administrator, the developer, and all these people who are tackling this or who are managing that application. I will be informed about this vulnerable container which is running on site inside the OpenShift. So they will be informed it. Then we'll run that container. So this is similar to you can take a server as an example. So Linux server. So where we have two types of commands. One command is a privileged command, another is a non-privileged command. A regular user can run a non-privileged command, like you can run ls list command, date command. So you can create directory, you can create files. So these are the non-privileged commands. So when it comes to the privileged command, like creating a user, modifying the password for the user, this type of commands, or installing some package. So this types of commands are privileged commands. Normal users cannot run that command at the server level. So if the normal user want to run this command, what we have to do is we have to do a privilege escalation. So how we'll do the privilege escalation at server level? We have to put a sudo entry for that user. Then when the sudo entry will specifically you give a access to a particular command, particular privilege command, we give access to that user, or we can give a complete access to that depending on what is the user role. So we'll give access to that user so that the regular user can use sudo and able to execute that particular command. He can use his own credentials and he can execute that command and he'll able to work with that privilege command. So that's what we follow that in the server level. Same thing, we have to follow this OpenShift platform level. We are going to follow something, we are going to do a privilege escalation to work around how to run this. So the basic idea is, so the restricted mode is not going to allow me. So this is the criteria of restricted mode, it's not going to allow me. Then what I have to do is I have to change the mode. So from restricted to some other mode, which mode I have to change. So I have 8 different modes. In the 8 different modes, I have to change to one of the modes to run that application. So that mode is, I'm going to change to some mode called any UID. So I'm going to change to this any UID SCC, which is the most privileged one. So in this any UID SCC, it is going to run, it is not going to see whether it is a root process or non-root process, both it will allow. So if it is a root or non-root, any UID SCC will allow that container to run, if it is, even if it is a restricted or not restricted, if it is a root or non-root. So we have to change the mode to SCC. And how this is identifying whether it is a root or non-root. So you might have a question like, I have an application here. So this application is running, the restricted SCC is allowed. How this SCC is able to find that this application is a non-root. So how it is able to identify it, whether it is a root or non-root. So previously I have created one file system. So I think you might have remembered that. So here I have created a file system. Okay, I'll just complete that. So when I take a remote of that thing, and I created a so here I created a file system, and if you look at the user of that file system, you can see this is the user ID. So it has some random number over here. This is the user ID of this file system. That means this is the user ID of that container, and this container, this user ID has to be matched with the project user ID. So any project you are creating, the project will have a user ID range. Okay, so here you can do this project. The current project is my current project, my demo 3. So if you describe this project, OC describe project, the name of the project is my demo 3. So if you describe this project, you can find over here ACC UID range. So you can see this ID which is there over here, it's matching to this. So this is how it's going to any project you are creating, it will have a default user ID associated with that. So it is going to create any application you are creating inside that project, that has to have that user ID. So non-root user ID. So that will have that ID. If that ID is fitting in this range, so starting from here up to 10,000, the range is like 1, 2, 3, can go on up to 10,000. If it is fitting in this range, so it is a starting range. You can see this is the range. That means that is a non-root container. By this way, the OpenShift is able to identify that container which is running over there. It is a non-root container or non-root process. You can see. And one more thing, like it's able to do that. So now once you describe this ACC, I'll just go to the other terminal. So once you do OC get ACC, so here you can find 8 different types of ACC. I'm just making it small so that if I do make it big, it will be collapsed. So I'm making it small. Here you can see the any UID, which is the first one. So in the any UID, so the restricted is the last one, the least privilege. Here you can see the strategy, the running strategy. So there are many strategies are there, like file supplementary group. There are different strategies. That is the security concepts. You can learn more about that, the security paper. So here we are going to interested in this run as a user strategy. So the SEC is using a strategy here. You can see if you look into the restricted SEC, here it is using a strategy called must run as range. So which range it is pointing out? To the range of that particular project. If it is in that range, this restricted SEC will allow that particular container to run. And if it is not in this range, what I have to do is I have to change the mode. Like I have to change from the restricted to any UID. Reason for changing to any UID is that the any UID strategy is different. So here you can see the any UID is using a strategy called run as any. So run as any means any UID. So whether it is a root or it is not root, whether it is in any range or not out of that range. So it is going to allow me to run. So this is what any UID. So you can find other SECs also having the same, like host mount any UID. It is also having the same strategy. You can use this also to run it, but when you use this one, it will impact other security concepts, other security things. Like you can see here, when you use this node exporter, it is going to affect other security values over here. So specifically, so if my use case is to just run that container, so I have to use any UID mode. So you can also use this one, but if you use this one, because this is also having the same strategy as the any UID. So if you use this one, it is going to affect other things, so we'll not be aware of that. So better to use this one. So as of this level of study, so we'll be using this any UID. So because my concept is to run the container with any UID, whether it is a root or non-root. So whether it is in that project range of ESCC or not in that range. So it is going to allow me to run that way. So what I have to do is, if I encounter any privileged container, so which is trying to run as a root container, in that case, I have to change. So restricted by default, it will be in the restricted mode. So restricted mode, it's never going to run it because it has changed it. It has its user ID changed, or user ID is not falling within the range of the project user ID or the pre-assigned range. So it is not going to allow that to run. So in that case, I have to change to the I have to change the mode of the SEC. For changing the mode, I have to follow through a privilege escalation process. So we are going to follow that privilege escalation. We'll learn about that privilege escalation process to do that. Okay, so this is the concept behind the SEC. So SEC is a very broad concept. So there are a lot of things are there in to go and describe the SEC. You can find a lot of things, a lot of technical terms associated with each and everything. But as of our curriculum, we are just seeing what are the use cases. Okay, I think my connection was lost sometime. Okay, so in our curriculum we cover so SEC, what is an SEC and what are the types of SEC we have. So we are seeing what is the SEC, so how you can utilize the SEC, how to see what are the SEC available. Then we'll see how to get the SEC. How we'll see this one later on. So this is a privilege escalation process. We'll see that later on, and we'll understand what is a privilege container. So these are the things we are covering basically on the SEC level. So, but there are a lot to the SEC. So you can do like OC describe SEC and find out a lot of things and terms associated with SEC. You can do like OC describe SEC. For example, you can take any UID. So any UID will have a lot of terms. We'll do that. You can see these are the terminologies. These are the access levels, priority levels, settings. So these terms will be sound familiar to if you are on security specialist side. So container security. So that level it will be familiar to you. So when you're just doing at the higher level course, there you will understand more about these terms associated with the SEC. But we are just restricting to how to use the SEC. Like we are just understanding one use case. So we're understanding what is a privilege container, and when we encounter any privilege container, how we are going to run that container. So that's what we are restricting ourselves. Okay. So to implement this, to see this in a practical way, I'm going to containerize an application so called WordPress. So you might be familiar with this one, WordPress application. The WordPress, which is a famous content management system. So we call the CMS system, where you can able to create your own websites and blogs, which is an open source. Using that, you can able to do that. So this WordPress application, I'm going to containerize it. So when I containerize this application, this WordPress has got inside it the PHP pad with the MySQL database and all these things. So it has got inside a PHP, say that business logic inside it, and it has a front end here. So, and also it has its own web server. So inside this, there is Apache web server running inside this WordPress. So why I'm choosing this application, why I'm containerizing this application, because I will encounter the problem of root privilege, because this has got a web server inside this container. When the web server container is going to run, any web server if you're running, so that web server will try to access the local port, try to get access the local port. For that, it requires a root permission. So it will run as a root container, try to run as a root container to access the local port to publish that particular web server. So when it's going to try to that, it will become a root container. So that's the reason I'm choosing this application. Will try to become a root container. So that when it's trying to become a root container, I'll be able to, we'll see that the SEC will prevent that. then we'll do the privilege escalation and see how to run that container. For that reason, I'm choosing this WordPress. And the image for that is available inside this QA registry. So you can generally also get it from the Docker Hub also. The same image will be available. So here you can find it in the Red Hat training. Under this repository, I have this WordPress image. So I'll be using this image to deploy the application. So initially it will be prevented, so the application will not run. So we'll do a privilege escalation to run this application. So here, let me just do WordPress. So here you can see the WordPress. So this is the application which you're going to use. And I think it has got some tag. The tag is 5.3.0. This is the tag of that image. So I'm going to use this image. So this is my image path under the QA.io training / WordPress as the image name. So let me now deploy this. So for some reason, I'm deploying this in the same project itself. So I'm inside this project, which is my demo. My current project is my demo 3. So for some reasons, I'm going to later on use the same image for some different examples. So for that reason, I'm going to use this inside this project, because I'll be connecting this MySQL, which is already running inside this with this application, which is the front end and the back end. So for that reason, I'm just deploying that in the same project. So already in this project, I have 2 applications running. So you can see that get ports. There are MySQL and PostgreSQL there. So inside this, I'm going to run the same application. So let me now do OC new app, the -name. I'm going to say this is WordPress. I'm going to say the Docker image. I'm going to say this is from QA.io / Red Hat train / it is WordPress. And I'm going to use the version 5.3.0. So if the version is used, if the tag is used, you have to use that tag. So here the image has got a tag here. So it has not got the tag latest. If it is not having the latest tag, that means I have to mandatorily use this tag. If I don't use this tag, you will see that image is we cannot able to pull that image. So you have to mandatorily use the tag. So if the latest tag is available, you can leave that as it is, without mentioning the tag. But if the latest tag is not available, then you have to use the specific tag which is over here. So I'm using that tag here to deploy the application. And we'll keep a watch also. So we already have a watch window. So we'll see what is going to happen to this application. So we'll see that interactively. Now I'm deploying this application. Now this is deployed. Now it is creating a container. And you will see that the application will go into the error state. So same like credential error. So it will go into the crash rollback of error state. You're going to see that. So once it is getting into the error state, we will analyze the log. So and see what is the problem. Now you can see this has gone into the crash rollback of state. And we'll analyze the log and know what was the issue. And actually there is no direct method. So now because I know by experience that this is going to be a privileged container, so I'm using this image. For as a developer or as a deployer, you will not have no idea about whether this is going to run as a root container or not. What you have to do is you have to deploy it in non-prod environment, identify the status of the container, how it is running, then you try to deploy this on the production environment. You can directly do that, because only at the deployment time I come to know that this is having issue. This is going to run as a root container. So unless at that time, I will not know whether this is going to run as a root container or not. And also there are other ways, like the developer of that image can communicate to you. So when you do that inspection of that image, in that description itself, the developer can mention this, like mention as a warning, this container will try to run as a root container. So if you see that warning, before testing itself, you can identify. But if the developer doesn't provide any information to you about this particular image, then you will not have any clue about whether this is going to run as a root container or not, a root container or a non-root container. Then you have to deploy it in the non-prod environment and test it, then analyze whether it is running the root container or not, or as a non-root container. Then you deploy it in the production. So if you directly deploy it in the production, you will face this issue. It will go into the error state, then you have to do a privilege escalation and all this. Okay, now I'll analyze the log, the OC logs. Now analyze the log of this one. Here you can see there is an Apache server which is inside this WordPress. This is trying to bind to the publish itself to the port. So port 80, which is a normal Apache default port, it's trying to access the default port inside the worker node. But when it's trying to access it, so it is prevented. So you can see that permission is denied. So who is denying the permission? The SCC. You can say the OpenShift is denying the permission for this container to become a root. So this is a security measure. It is scanning this application and see that it's trying to become a root container. So only the root container can access the port on the local host. So because of that, it's preventing that application from accessing it since it is becoming a root container. So root container is a privileged container. I can say it's a vulnerable container. So because if the root container is running, so through the root container I can able to entirely compromise the worker node. By compromising the worker node, I can compromise the cluster itself. So it's very dangerous. So we are going to prevent that thing. So as a security measure, the SEC is preventing that from happening. So now I got the issue. Now I know that this is the SEC problem because the permission issues, the permission denied, because there is no problem with the image. So image is already available. So there's no problem with the operations. I can able to deploy it. So deployment, everything is happening. The problem comes when it's trying to when it's trying to run in the worker node. So that's why the reason that we get the permission denied, and since this permission is denied, it can do nothing. So that's why it is shutting down. The application is shutting down. Application is not running because it is not able to, because without publishing to the port, the application, when it runs, there is no use of that application. So without that permission, it cannot do anything. The basic permission is required to publish that to the port, and only we can access that container. So as a reason, it is shutting down that the container over here. So now we understand, and we don't have further logs to check. So now we identified it. So now what we have to do is we have to do a privilege escalation. To understand the privilege escalation, normally what you can just compare with the OS server level. So what we'll do, so for privilege escalation, for example, running a privilege command, you will put a sudo entry in the sudo ES file. You'll open that file. You'll put an entry for that user. You will add the command to the user, and then you will save the level of privilege, like whether he can use his own password or whether he can use that command without the password. You will provide the privilege to that user. Depending on that privilege, the user is able to execute that privilege command. The like you can say the regular user and able to execute that privilege command. Similar to that, we are going to do it here, but in a different fashion. So here I want to prevent the user credentials. I don't want to mention the user credentials. I don't want to use here user credentials inside the. So when I want to do the privilege escalation, so instead of that, what we are going to do is we are going to create something called a service account. So we'll create something called a service account. For that service account, we will associate the privilege. So here we are going to create something called a service account, which is different than in the OS. So initially we'll create a service account. So we'll create a service account. So after creating the service account, for this service account, I will associate a privilege. So you can say the SEC privilege. For this service account, I can associate a SEC privilege. So in the main policy, we'll associate a SEC privilege with this service account. And this information, so I have created this and all these things. Since this information has to be mentioned inside the deployment. So whatever you have created, the service account and all this information about the service account has to be mentioned inside the deployment. So that is the application level. So you have to mention this one inside the application. Then only the application will check the service account and it will check the service account is having that privilege. SEC will check that what privileges it's having, and once it's checking the privilege, then it will, if the privilege is allowing that, then it is going to run this application. If it is the privilege is not allowing that, then it will again shut down that application. So here what privilege we have to add to that? So by default it is restricted, so I have to add a privilege called any UID. Any UID privilege I have to add to this service account. And why I'm creating a service account over here? So I can use like at the server level where we are using the user credentials and doing a privilege escalation. Like that I can do that here also. But we are protecting the integrity of the user. So by creating a service account here, there is no need to mention the user name and password. So this service account, which is universally created, so because the information about the service account, it will be there in the deployment file, in the application file. Then the configuration file, you have that information. So if instead of service account, if I am in a situation I need to mention the user name and password, I can run that application. But what problem I will face is the user is not a permanent entity. Maybe the user may be there in this project this time. He may have shifted to other project. He is not there in this project anymore, or he might have even left the company, so he is not there even in the organization itself. So in that case, but the user credential is still there. So whatever he has created, the application, that is credential is there. So there will be a problem in future when you're doing the upgrading process or something. It is going to try to look for that user. So the user is not there in the system. You will not able to deploy this application. You will face that problem. And also we are preventing the user credential from exposing. So once you are mentioning the user credential over here, somebody who is going to open this file, he will see the user credentials information, user information, user name and password information inside this file. So we are providing that integrity also. So that is the reason why we are going for service account. Service account is a universal entity. It is constant for a project. So it is not going to change unless you are manually changing it. Until then, it is not going to change. It's a constant for the project and it's constant throughout the cluster. So unless manually you change it, it will be there. So it's not going to depend on any users on that. And also you can mention the service account information inside the deployment. So it's not going to affect any in that. So it's not having any credential information, just a service account information. For service account, so the policy modification can be done by the main cluster administrator. So there is a reason we are going for this kind of. Okay. So now we are going to see how to do this privilege escalation process. Basically, what I am going to do is I am normally when I do OC describe pod. So if I grep pod WordPress. So here, if I grep the SEC over here, you'll see that it is in the restricted mode. So here, through the privilege escalation process, I am going to change the mode from restricted to any UID mode. This is what I'm going to do over here. So let me open another tab. So here, we'll start the process. So it's going to go through the different users. So first in the project, so as a developer, so what I did is I deployed the application. So as a developer, I deployed it. So I deployed the application. So what was the result of that deployment? It was in the error state. So I'll analyze the log. There was a permission issue with that. So when I do OC get pods, here the WordPress, you can see that WordPress is in the error state. So the cache backup error. Reason was identified that from the logs that it was not having sufficient permission because restricted mode is preventing it because the container tried to run as a root container. So this is what I identified as a developer. So I analyzed the result and I come to a conclusion that there was an issue with the process or issue with that SEC. So I cannot handle this individually. So what I will do is I will raise this issue to the project manager. So one who is in charge of this project. So I'll escalate this issue to the project manager. And in some cases, the developer itself may be a project manager. In this case, he can create the service account. But here, just we go the proper procedure. So the issue will be escalated to the project manager, or one who is responsible of the project, one project admin. So in both cases, developer may be the same as the project admin, or in some cases, most cases it will be different. So developer will be just deploying the application. The project manager will be taking care of the projects, different application, managing different application. So the issue will go to the project admin. And what the project admin has to do is he has to create a service account. So that's a privilege screen. That's the first step. He will create a service account. So you will just use, here I'm not switching any user here. Just I'm mentioning the role over here. The real time actual user will do. So you have to raise a ticketing system. You have to raise a ticket to that. The ticket will reach the concerned authority, and he will do this process. Here I'm not doing that anything. So here I'm doing that as all this is a simple single user, as a kubeadmin user, because kubeadmin user will have all the privileges to do all the things. But in the real time, you may not have privilege to do these things, these actions. So only the particular authority will be doing that. So as a developer, I can deploy it, but to create a service account, I will not have any permission. But here I have a permission because I'm doing everything as a kube administrator who is having a full authority on the cluster. So I'm just mentioning the role who will do that in the real time. Okay. So here I'm going to create a service account. The service account, you can give any name for the service account. You can say, I'm going to say this is a WP admin, WordPress admin. Any name you can give. So it's not a constraint. So with anything, so you can give any name for that. I'm just simply saying WP admin. So this is the service account. So now you can see in this project, OC get service account. You can see the service account is created. So we have some default service account in this project. So you can see that additionally a service account is created. Okay. And once the service account is created, it has no value now. Just it's simply a service account. To add a weightage to the service account should have some kind of privilege or some kind of a weightage to it. Then only we can do something with the service. Otherwise, it's a dummy value. So I can just get the dummy service account now. Now I want to add a weightage to it. So what is my aim is that I want to through this service account, I should be able to do a privilege escalation. So my aim is to change the mode. Like my aim is to change it. My aim is to add a privilege, SEC privilege to the service account. What privilege I have to add is any UID mode. So here, who can do that? Now the project admin cannot do this. So he created a service account, he can create it. And he has to escalate this issue to the main cluster architect, so or the main cluster administrator, so who is responsible of managing or creating the cluster or managing the policies of the cluster, entire cluster itself. So the issue will go back to them. So from here, the issue will escalate to the main cluster architect. So who is responsible for managing the entire cluster. So the issue will go to the main cluster architect, or you can say cluster administrator. That will go to them, and he can only modify the policy. So in the policy, he has to say this service account has this role, or it has this SEC privilege. He has to say that. So through the policy, so he has to modify the policy. So he will be doing OC ADM policy, add SEC rule to the user. So here the user, actually I'm saying a user, the user represents the service account actually. The service account is also a kind of a user. Later on we'll see. It's like a substitute for the user. So it's not actual user, but it's like a kind of a substitute for the user. That's why we're saying add SEC to user. And here what role I'm going to add. So I need to add the any UID mode, because any UID only is going to allow to run any container, because the strategy, if you look at the strategy of the any UID, you can see the strategy here, run as any. So it is not, the application is not running because it is not in the range. The restricted mode is not allowing, must run as range. It is not allowing that because it is not in that range. That's why it's not, it is restricting that application from running. So I need to change to any UID, because any UID is having that particular role. So I'll go to this again. So I'm going to create any UID role to this, and I'm going to mention the service account. Since here I'm mentioning the user, since it is not a normal user, it is a service account. To emphasize that, I'm using here -z option. So Z option says this is a service account. So this is not a regular user. This is a service account. Even though I'm mentioning here the user, so it is doing the function of a user, but it's not a user, real user. So it's just a service account. So it's a substitute account for the user. So I'm going to mention, so I'm going to iterate that using the -z option. Here I'm going to use any UID. Here I have to use the service account name, WP admin. I have to use that name. So I'm going to add that service account. Now this is added. So you can check the cluster level. You can check this policy, like OC get cluster role binding -o wide. So here you can grep for this role, this service account name. just I'm checking that in the overall policy. Just I'm graphing it. So this will actually provide me a lot of standard output. So here just I'm graphing that required information. Here you can see the WP admin service account. Now inside this project, my demo 3, this WP admin has a privilege. You can see SEC, any UID privilege is there for that service. It has got a role. Okay. Now we have ensured that this service account now is capable of doing the privilege escalation. So because the cluster administrator, so in real time the cluster administrator will get the required details or get the required information why they want to run it. So what is the reason for running that? So after running that, so then we are going to create that policy. So here we are doing all these things. So technically we are not going to modify anything. Still it is going to run as a root container only. Are involved, the project administrator, the cluster administrator, all the people in the line are involved, so that they keep track of this vulnerable container running. So because there is no choice, we have to run it. So in this scenario, so we have to go through this procedure, even though we're not doing anything here. So we can do it technically, but if I do that modification technically, like if I change the user ID, so may not be the container working, will not work properly. So because it has to have a root privilege for doing some function, mandatorily we should have it. So without that, it's not going to work properly. So for that reason, we have to run that as a root container. Okay. All right. So we have done that. So, but still, the application is in error state. So if you look at the application, still it is in crash to backup error. So what we have to do, finally, we have to patch this information. So we have done these steps. We have created the service account. We have added a privilege to that by the policy. Finally, this information has to be there inside the application, because the application has to know that this service account, using that we can do a privilege escalation. So you have to patch this information inside the service account. So inside this, inside the deployment. So there are two ways to do that. So here, finally, the things come back to the developer. Now, project admin, the cluster admin, their roles are complete. The developer now, the escalation comes back to the developer. Developer, what he has to do is he has to do the patching operation. So we have to patch this information inside the application, inside the deployment file. It's called a patching operation. So there are two ways to do that. One is using the command line. You can do it. So it's very easy to use the command line. You can use something called OC set service account. OC set service account. So you mentioned the name of the deployment. The deployment name here would be WordPress. The WordPress, and then you mentioned the name of that service account. The name of the service account here it is WP admin. So this is WP admin. Using this command, you can set it. It will directly set that this will do the patching operation. What it will do is it will modify, it will add a service account to the deployment file. So through this command line. So we can do that imperatively. So using this command, this is one option. Other option, I can directly modify that file. The Kubernetes way, like I'm using the declarative architecture, I will open that deployment file, go to the deployment file, I'll add this information at a specific location. So if you know where to add it, you can directly go and do that. This is a Kubernetes way of doing adding that information. So here, the OpenShift way, there is a command. Okay. But in the OpenShift, you don't have command for all the things, but certain things, important things, you can have a command to do this. So for other things, we have to do the Kubernetes way. But some I'm going to do the edit operation, OC edit. I'm going to directly edit that file, OC edit. Deployment, name of the deployment, which is WordPress. I'm going to edit this file. So I'll go to the spec section and just scroll down. We'll go to the specification section. So here you can find the specification section. This is where the definition of replica set starts. Here the definition of from the template, the definition of the pod starts. Under the pod, I have the container. So under the specification, I will mention the service account name. Here I can mention that. Here I'm going to mention this service account information. I just say service account name. The name of the service account, which is going to be WP admin. This is service account information. So I'm mentioning that inside the file. So after mentioning that, I'll going to save this file. So immediately after saving this file, so I did some modification, a configuration modification here. So what will happen is that it is going to re-trigger. So it will re-trigger that application. During the re-triggering process, it will see the service account information, and it will go on then the OpenShift installer will go and check. OpenShift will the SEC will check the NUID. It will check the service account. After checking the service account, it is going to check the policy, whether this service account is having the privilege or not. If it is having the privilege, it will change the service account. It will change the mode. So whatever the service account has got the mode, it will change to that mode. So previously by default it will be restricted. Now it's checking that everything, and it's going to change the mode from restricted to any UID. In the any UID, this will allow that container if it is a root or non-root. So here it is a root, so it is going to allow that. So then you are going to see that that particular container is going to run. So this is the privilege escalation process which we are going to do. Now I will save this file. So once I save this file, you can see the edit information. So now I go here, you can see it started creating a new container. Now it will check the policies, and it will change the mode of SEC. So after some time, you'll see this going to run. So once it is running, then we'll go and check the nature of that container. You'll see that the container will be running as a root container. So we'll see that we have to prove that fact. So it is going to have a user ID which is not in the range of that project. You will see the user ID to be the root itself. Now you can see it has started running. So the WordPress is now running. So this is how the privilege escalation process works. Once it's running, now you can compare it. Now you can see previously when I do the description of that previous pod, it was having the SEC to be restricted. Now if I do the same, we see describe pod WordPress. If I do grep of SEC, now you see the SEC will be changed. So SEC will be changed to the NUID. So that's the reason why it is allowing to run. So why the OpenShift is allowing to run that container, because the NUID, the range is any range it will allow. So it will, if you look at the description of the NUID, you can see run as any. So previously restricted must be in a range. The range of that project UID, SUID definition, so it should be in that range. If it is not that range, it will not allow it to run. And now we can verify the fact. Previously we have verified that we were into the particular thing. Here we can see when I do when I create that my file, you can see this was the user ID of that container. And now I do the same thing. I'll go to the I do OC RSH WordPress. So here itself you can see the change in the shell. You can see this is a root shell. So the pound symbol indicates that's a root shell. So, and here I create some file. I just use touch command. I just create another file system file here, file.txt. So I check that file. I check the ls hyphen. So if you check the file now, file system which I have created, here you can see this is root. So the user is root, but previous case the user is not root. So it was in the range of that SEC UID of that project. So now in this case it was not in the range. So that's the reason why the OpenShift was preventing that application from running that container. Just to see what user that container is running, and just creating on a file and just finding. This is an easy method. There are other methods to do that, but this is an easy method. Other method is just we have to go to that directly where it is running. You have to get the UID and you have to see that all these things. But it's an easy method to know as what user it is running. So here you can see this is running. If you create any file system, so that will be the ownership. That will have the user ownership. So here you can see that that's the ownership of that file is having some random user ID which is falling in the range of the project. If you just look into that, if you do see describe project, the project which is my demo 3. So here you can grep for SEC. Here you can see this is falling in this particular range. So that's why it is classified as a non-root. So here it's not in that category, so it is a root. So the user root will be normally 0. It is not in this range. So that's the reason why the SEC was preventing it, restricted SEC. Then we have changed the restricted SEC. We followed this particular procedure for that. So we followed this procedure. So as a developer, we deployed it. It was in Crashflow backup error. Then as a project admin, we created a service account. For the service account, we have associated the anybody with a policy, and we verified that. Then we patch that information. So for patching, we have two ways. One, you can use this command to patch it. So it will do the same thing. I just directly edited that file. It will do the same thing when you do this. So this is a command way you can use it, but you also, it's better to know the declarative way. So just going directly and editing that file, the specs about the container, you can add that information. Then you will see that the application was getting into the running state. So with that, we complete this session. So we are just touching the tip of an iceberg. So there are a lot to the SEC. You can use SEC for a lot of use cases. So there is a lab to this. So on page number 104 on the book, there is a lab. So in the lab, what you're going to do is you're going to deploy the similar kind of an application. Here the application is called GitLab. So you're going to deploy some application called GitLab. You will deploy this application. You will see that application will go into the error. Then sometimes after it will go to the cache backup error. Then you use the oclogs command to check what is the problem with the application. You will see that the permission will be denied. So there is insufficient permission on the worker node. They will get that in the logs message. So once you see that, then you will follow the same procedure. You will just create a service account. Then you will add that to the policy. Then you will set that service account to that application. Then you will see that application will be running. Then you'll do a expose. You will expose this application. Then you'll see that you'll get a URL. Using the URL, just curl that application, see whether it is reachable or not. So this part is just related to the networking things. You can do that later on. So we'll see this later on. So now we can finish this lab. It will take like 15 minutes of time to finish this lab. It's a very small lab. So even though we have a lot of concepts, but the lab wise, it's very small. Like we're creating a project, we're deploying application. Then you see that the application was having insufficient permission. Then you create a service account, add a policy to the service account. Then get that to the application. So just pass that information to the application using the command. Then you see that application will be running. Just expose that and see that the reachability of the application. So that's all you're doing. Very simple. Like you can finish it in 15 minutes of time. So you can finish it by 12:45. Now it's 1 o'clock. So you can finish by 1 o'clock. We'll start the next section by 1 o'clock. So we'll have a half an hour of a session, like 1 to 1:30. Then we can have a lunch break. Then instead, so we'll start back by finish this lab on page number on 104. So we'll start back by 1 p.m.